Good morning. We're going to be going over some review material that you will need so that you can work on the Unit 5 review on either Monday or Tuesday. So what you're going to need out is binder paper because you're going to be writing your work and turning it in at the end of the period, and a pencil or something to write with. So quickly get those materials now and be ready to begin work. Okay, you should have binder paper out and a pencil. And while you finish getting those out, I'm going to go over our goals, what we're learning, why we're learning it, and how you'll know that you've been successful. So we're reviewing major concepts that we've covered in Unit 5 in preparation for the unit assessment. Why we're learning this? Well, it's important to do your best on any assessment that you're taking, and being able to review important concepts is a way to help yourself to be successful. And how will you know that you've been successful? Well, one, you'll be able to explain product and process for order of, that should be of, operations, identify keywords and operations and expressions, translate from English to algebra, and use decimals to find your percent of increase or decrease or discount or taxes. So here we go with order of operations. So on your paper, I want you to write GEMS and what GEMS stands for, and then copy down both expressions. And we're going to work through these to see what your answers should be. You should be writing down GEMS, and then under the GEMS, copying down both expressions. Copy them side by side because you're going to need room to work out the order of operations. Okay, so let's start with the first one. 54 divided by parentheses 4 plus 5 parentheses times 7. Well, I'm looking at my list here and groupings. Well, this is what I have here for groupings. So I'm going to start here. I'm going to bring down 54 and my division sign. 54 divided by 4 plus 5 is 9 times 7. So now I have to look at what my next step is going to be. Well, there are no exponents, and I have multiplication division. This is where some people might make a mistake and go, oh, multiplication comes first because it's listed here. But the remainder of this listing is multiplication, division, left to right, whichever comes first. Left to right, 54 divided by 9. 54 divided by 9 is 6, and I bring down times 7. 6 times 7 is 42. And you should have all of these steps listed on your paper. We did groupings, no exponents. We did division because it came first, and then multiplication. And our final answer is 42. So let's take a look at the next one. I have 125 divided by 5 to the second power times 3 plus 5 subtract 2. Again, I'm looking at groupings. 5 subtract 2, that's 3. I'm going to bring everything else down. Copy my division sign. 5 to the second power times 3 plus 3. Now I look at what do I need to do next? Well, I do have exponents. 5 to the second power is 25. Remember, 5 to the second power is 5 times 5. I'm going to bring down the 125 times 3 plus 3. Now, take a look at what you have left, and I want you to work the rest of the problem out. What were you going to do next? What would your following step be? And what would the last step be? So take about 45 seconds and indicate your following steps and why. Okay, let's check and see how you did. Well, I have division, multiplication, and addition. And again, we're going to take a look at multiplication, division. Well, that's true, but left to right. So left to right, I am dividing first, then multiplying, then adding. 125 divided by 25. I'm going to have a quotient of 5. I'm going to bring down times 3 and then plus 3. Okay. So my next step is 5 times 3, 15, plus 3. 15 plus 3, that's 18. And I am certain that you got the same answer, 18 for your final answer with your order of operations. And remember, you should have all of this written down. And you know that grades are closing on the 16th, but I am not going to get these papers until I return on the 19th. And this will then become your first grade for fourth quarter. So it is going to be graded. It just won't be in time for the end of third quarter, since that is on the 16th. And also make sure your name is on your paper. Double check it right now to make sure your name is at the top. And now, solving equations. Julie needs 21 2/5 cups of flour to make biscuits for the restaurant. She has 10 1/5 cups. How much more flour does she need? Well, she needs a total of 21 2/5. So this is going to be how much she needs altogether. That's her total. This is what she has, 10 1/5. How much more flour does she need? Let's take a look at our equation here. This is what she has, 10 1/5. This is how much she needs to have altogether, 21 2/5. 10 1/5 plus how much more is going to equal 21 2/5. Pause the video here, and I want you to take about a minute to a minute and a half and see if you can determine what your answer is going to be. So pause here and come back in about a minute to a minute and a half. Okay, so let's see what you did here. I'm looking at if I have 10 and 1/5 and I have another amount that needs to equal this. Well, this is an addition equation. The opposite of, or the inverse of addition is subtraction. So if I take 21 and 2/5 and I subtract 10 and 1/5, that should give me my needed amount here. Because I'm dealing with fractions, I'm going to look at my denominators, and I notice that both denominators are the same. So I don't need to worry about finding a common denominator. I am going to subtract. I'm going to subtract my numerators, and then I'm going to subtract the whole numbers. The denominator, since it's the same denominator, it's going to remain as 5 or fifths. To subtract 1, that's going to give me 1. 1 subtract 0, well, that's 1. 2 subtract 1, that's 1. And I have 11 and 1/5 as an answer. Well, I also want to make sure that my answer is reasonable. So I know that I can plug it back into the equation. And when I add these two together, I should get 21 and 2/5. So let's check that out. I have 10 and 1/5 plus, remember, I'm checking my work now. So I'm adding this difference back into my equation. 11 and 1/5. Again, my denominators are the same, so I can add the numerators. My denominator is going to stay fifths. 1 plus 1 is 2. 0 plus 1 is 1. 1 plus 1 is 2. And I get my answer back again. So I know that my answer is reasonable, and I know that my answer is correct. Good. Now, let's take a look at the second one. Jose has 3 times as many model cars as Tom. Altogether, they have 48 cars. How many cars does Jose have? Well, I know that he has 3 times as many. So this is going to be 3 times, I'm going to put C for cars. That's how many cars Jose has. 3 times the number of cars as Tom. That means Tom has C cars. I don't know how many he has, but I do know that altogether they have 48 cars. So my equation is 3C plus C equals 48. Well, we've done a number of these over the past week and a half. So again, pause the video here for about a minute. And I want you to write out this equation and I want you to solve it. And then find the number of cars Tom has and the number of cars Jose has. Okay? 1 minute, go. Okay, so checking back. Well, I'm looking at 3C plus C equals 48. And I know that I can combine like terms. 3 times C plus C is going to give me 4 times C equals 48. Well, this operation is multiplication. The inverse of multiplication is division. So if I divide both sides by 4, that's going to give me the answer for C. 4 divided into 4 is going to give me 1. 48 divided by 4 is going to give me 12. So C equals 12. But what does this represent? Well, this is Tom's cars. Tom has 12 cars. Jose has 3 times as many. So Jose, to find his answer, that's going to be 3 times 12. And 3 times 12 is 36. Again, I want to make sure my answer is reasonable. So I'm going to take the number of cars that Tom has, the number of cars that Jose has, and I'm going to add them together. And if my answer is correct, I should get 48. Six plus 2 is 8. 3 plus 1 is 4. And I got my 48 back again. I also know that I can plug the variable that I got, or the answers that I got, back into my equation, and it should balance. Okay, so if C equals 12, 3 times 12 plus 12 equals 48. 3 times 12, that's 36, plus 12 equals 48. Well, 36 plus 12, 48 equals 48. And my equation is correct. Nice job. Now, let's take a look at this one. Quinn practices her cheers for 30 minutes after her doctor's appointment. She practices some more before bed. Write an equation that shows the total number of minutes that Quinn practiced. Use the variable P for the total minutes practiced. So, pause the video here. I want you to discuss this one with the person sitting next to you. Then I want you to write the equation. Okay? Pause here and go. Okay, let's check back in. Quinn practices her cheers for 30 minutes after her doctor's appointment. So I know that she's practicing 30. She practices some more before bed. Write an equation that shows the total number of minutes that Quinn practiced. Use the variable P for the total minutes practiced. Total minutes is going to go here. I don't know how long that is, but I know it's going to be represented by this variable. Okay, So I'm going to put M here for more practice. She practiced 30 minutes. She practiced some more before she went to bed. So M is going to be for the more practice. And this tells me to use P for the total minutes practiced. So I don't want to keep these two variables the same because this represents total number of minutes. This here is not going to represent total number of minutes. It's going to represent the minutes, the additional minutes that she practiced before she went to bed. We don't know what the total number of minutes is, and we don't know what the additional practice here is. So this is the best that we can do in writing the equation because we're not given this value and we don't know this value. So we have translated the information here into English, into math. Okay, distributive property. We see this everywhere. And we've been practicing writing an expression as the sum of exactly two terms in math class. So I want you to work on this one. And then I want you to write equivalent expressions for this and equivalent expressions for this. Think of all the different ways that you could see these expressions and then include those in your answers. Okay? Pause the video here for about 3 minutes because I think these two you're going to need to think about. And then come back in after 3 minutes and we'll check and see how you did. Okay, pause here and we'll come back shortly. Okay, so I want to write this expression as a sum of exactly two terms. But remember, we have 3 terms here right now. I have multiplication and addition, and I want exactly 2 terms. And because this is sum, I know that I need to have addition. Well, distributive property tells me to multiply the number on the outside by the numbers on the inside. 15 times 3, that's 45. And that's going to be 45A. Plus 15 times 5 is going to be 75B. There's 1 term, there's 2 terms. So I have taken this expression and I have written it as the sum, addition, of exactly 2 terms. Now, I need to find equivalent expressions for this expression here. And I'm looking at this and looks to me like this is the distributive property. Instead of just 2 terms inside the parentheses, there's 3. So let's check and see how you did with this. I know I can multiply 12 times 3, and that's going to be 36B plus 12 times D is 12D plus 12 times 2D is 24D. So I have distributed to all of these terms here, but I'm looking at this here, and I'm thinking the variable is the same. Can't I just add the coefficients? And yes, I can. So this is one way that I can write an equivalent expression, or I can write 36B plus 12D and 24D is 36D. Now, write equivalent expressions for 4A plus 4 plus A plus 6 plus 5A. Well, if I'm looking at this, I'm thinking I can combine the A's. I can add like terms. 4A plus A is 5A. 5A plus 5A is 10A. And then I have 4 and 6. 4 and 6 is 10. So there's an equivalent expression, but I'm looking at 10A plus 10. And I'm thinking I could also rewrite this as the distributive property. But what would that look like? What would I have for all of this here if I have 10A plus 10? Well, I could have 5 times 2A plus 2. Would that give me the same thing as this? And if I multiply 5 times 2A, that's going to give me 10A. And if I multiply 5 times 2, that's going to give me 10. I could also look at this and say, well, maybe I'm not factoring out 5 and 2. Maybe I'm just pulling out the 10. And that would be 10 times A plus 1. And again, 10 times A is 10A plus 10 times 1 is 10. And if I take this 10A, I can break it up into 4A plus A plus 5A. And if I take the 10, I can break it up into 4 plus 6. Well, let's take a look at this one here. Can I do the same thing with this? If this is 36B plus 36D, what could I factor out? And if I look at what's up here, I could pull out a factor of 12, and I could have this plus 3D. That could also be an equivalent expression. And then I can take the 3D and I could also rewrite it as D plus 2D. So looking at the distributive property, when you have it in the regular form that you usually identify with, and then looking at it after the numbers have been broken apart, is important to be able to see it both ways. So this one had a lot of different steps in it. Hopefully you were able to see all of those different parts, or at least most of them. Equivalent expressions. Determine if these expressions are equivalent and be ready to explain your reasoning. Well, I have 12A plus 12C. Is that the same as 4 times 3a plus 3c. 12a plus 12c, is that the same as 24 times a times c? 12a plus 12c, is that the same as 4 times 3a plus 4 times 3c? So pause the video here, take about 2 minutes, and discuss with your partner. Are all of these equivalent? Is only one equivalent? Are two equivalent? Which ones? And be ready to justify your answers. Okay? Pause here, 2 minutes, and go. Okay, let's check back in. So I'm looking at 12a plus 12c. Well, if I distribute this 4 times 3 is 12a. 4 times 3c is 12c. So are these two the same? Yes. And they're the same because in this expression here, the 4 has already been distributed. I can pull out a factor of 4 times 3. I can pull out a factor of 4 times 3, which gives me this here. Now I'm looking at the next one. 12a plus 12c is the same as 24 times a times c. Well, I'm looking at the coefficients. 12 plus 12 is 24, that's true, but the variables are not the same. These are not like terms. I cannot add the coefficients together and then multiply the two variables together. So no, this is not the same thing. Okay? These are not like terms. I cannot combine them to get 24. So looking at the last one, 12a plus 12c is the same as 4 times 3a plus 4 times 3c. Are those the same? And I say yes, they are, because again, I can pull out 4 times 3. That a is going to go along with it. That's what you have here. And 4 times 3c, and that's what you have here. So these are exactly the same. Okay? Now, I did not tell you to write down, or I don't think I did, these expressions and your answers. So if you did not do that yet, take another minute and write down your expressions, the answers, and how you determine the answers. So pause the video here for a moment or for a minute, and then check back in. Make sure everyone has written all 3 of these statements out. And we'll be back shortly. Okay, so you should have had time to record all of this down. And again, the reasons why that these are equivalent expressions. Now we're looking at inequalities. We've done this most recently. Remember the inequalities of less than or greater than. So this inequality, x is less than -3. What are some possible values for x? What are some values that are not true? Well, I'm going to list some values here that are true for x, and then I'm going to add some values here that are not true. And this is saying x is less than -3. So I'm going to think of a number line. Okay, I have 0. There's -1, -2, -3, -4, -5, and I can keep going further on down the number line. I can also go this way on the number line. And then I've got 1, 2, 3, 4, and I could keep going for 5 and higher. So I want values first that are true, that x, whatever x is going to be, is less than -3. Well, if I go to the right of the number line, these negative numbers are larger than -3. So some true values are -4, -5, -6, -7, -8. All of these would be true statements. -9. So if I keep going to the left on the number line, all of those negative numbers would be true statements. They are all less than -3. Well, what's not true? Well, if I go to the right, -2 is not less than -3. -1 is not less than -3. 0 is not less than -3. And all of my positive numbers are not less than -3. Put commas in between here. So these are numbers that will make this statement true. These are numbers that will make this statement not true. So if you have not written this down yet, write your inequality and then write true and values that make it true, and not true or false and values that make it false. Okay, so now let's look at our last one. And this is basically the same thing, except we're going greater than. So I have y is greater than -1. And I want values that are going to make this true and values that are going to make this statement not true or false. So again, if I look at a number line, here's 0, here's -1, 0, 1, 2, 3, 4, 5, and going up, my positive numbers will get larger. Going to the left of the number line, -2, -3, -4, -5, and the further to the left I go, the smaller the value of the negative number goes. So I want values for y that are greater than -1. So greater than -1, 0 is greater than -1. 1 is greater than -1. 2 is greater than -1. 3, 4. Okay, all of these are greater than -1. What numbers are not true for greater than -1? Well, -2. -2 is not greater, it's to the left. -3 is not greater. -4 is not greater. -5 is not greater. All of these integers, or all of these numbers to the left of -1, this is what I'm looking at, all of these numbers to the left are not true. These are not greater than -1. All of these values are true because they're greater than -1. So drawing a number line can help you determine, if you're not quite sure, look at the number line and then make that determination for what's greater than or what's not greater than based on the inequality that you're given. Okay? And that concludes our review for today.